Hello and welcome to the companion video for the River Crossing Challenge. And if you haven't already watched that, then it is linked in the card and in the description, but don't worry too much because this video is mainly going to be about the maths of the Seven Bridges of Königsberg, the puzzle that inspired the River Crossing Challenge. Now, Königsberg was a city in Prussia, now in modern-day Kaliningrad, and it was built near the mouth of the Pregol River, and comprised of the land on both banks of the river, as well as two islands, Alstadt and Vorstadt. I have no idea if I'm pronouncing those correctly. And as the title suggests, there were 7 bridges, which I have represented in light green, that connected various bits of land. Okay. Now, there are many stories of where the challenge originated, but the rules were always the same. You must find a route that traverses each bridge once and only once, okay, without accessing land via a method or other than a bridge. So basically no swimming or taking a ferry from here to here, say, okay, and the definition of accessing a bridge means you have to cross it fully. So once you've walked on, you can't just go halfway and come back the other way. You have to cross the whole thing. Okay, so, we can go ahead and try and solve this. So let's start here, say. Okay, and we can go up these 2 bridges, along here, down those 2 this time, onto this bridge and this island, but then we're stuck. Okay, because if we went over this bridge, well, we'd be on this island, but we won't have covered this one. But if instead we try using this bridge, well, it's the same thing. We'll be stuck over on this bank, and we won't be able to get to this island because we've used these 2 bridges. Okay, so I mean, let's try again. Okay, let's give it another try. Okay, this time let's start in the island in the middle. Okay, and well, let's cross this bridge first, get it over and done with. Okay, and then we can come down over this bridge. Okay, go up here, and then up another one of those on that side, and then onto the island again, and down onto this bank. But then we're stuck again because we still need to get this bridge, but we're stuck down over here and we can't get to that because we've already crossed this one. So it seems unsolvable. Okay, and frankly it is, but the problem went unsolved for many years. Okay, no one knew for certain whether it was definitely possible or definitely impossible. And it wasn't until Swiss mathematician Leonhard Euler came along and basically invented graph theory to solve it. Graph theory is the study of networks of nodes connected by edges. For example, the tube map, that is a graph because it shows various nodes, the stations, and how they are connected, the tube lines. Okay, and this was Euler's big breakthrough. He realised that the standard map of Königsberg, okay, contained a lot of useless information, and so he streamlined the problem into one that looked like this. Okay. So we have. So what he did was he said, well, we can shrink the land masses down to points because the shape of the land doesn't really matter. What's important to us is the crossings. Okay, the bridges in this case. Okay, so if this is the north bank, then we have 2 bridges going to the island in the middle, and 1 bridge coming down over here to this island. Okay, we've got another 2 bridges to the south bank, and another one connecting the island there. Okay, and then one bridge in the middle connecting the middle island to the other one. Now his next observation was that apart from your start and end nodes, you will always enter a node via a bridge and leave via a bridge. Okay, what that means is that, you know, suppose I was on this bridge and I'm coming into this node. Okay, well I have entered it and then I have to leave it as well. And if you're going to do that, by the rules of the challenge, you can't go over the same bridge more than once. Okay, so what does that mean? It means that the number of times you enter a vertex or a node, that's going to equal the number of times that you leave a vertex, barring the endpoints. Okay. In turn, what this tells us is that for a path to exist, we must have either 0 nodes of odd degree. Okay, so the degree is just how many edges are coming out of your node, or exactly 2 nodes of odd degree. Now, if we look at our simplified map of Königsberg, well, we can count the number of edges coming out of each of these nodes, and we've got 3 here, 3 here, 5 here, and 3 here. They are all odd. Okay, so neither of these criteria are satisfied, and therefore this is impossible. You cannot find a path around this network without having to cross an edge or a bridge, you know, whatever, more than once. Okay, now if we take a look at my map of the river crossing challenge, okay, which I have so artistically drawn, okay, well, we can count the number of nodes, okay, and what their degrees are, but I mean that's effort, and I can tell you that all of them will either have degree 1, that is the start and end point, or degree 2, which will be basically the rest. Okay, which is why the river crossing challenge was possible. Okay, and you know, so I started over here at Gunnersbury, down to Richmond, all the way round, all up over there. Okay, up. Did the Northern and Bakerloo lines at Waterloo, and all of this, cable car, Elizabeth line, etc. I did the lot. Okay, and if you haven't watched that, then as I mentioned earlier, it is available to watch. Okay, and you can do that here. Otherwise, that was the 7 Bridges of Königsberg. I hope you enjoyed the video. If you did, then hit like, hit subscribe, do all the things, and I'll catch you in the next one.